Assalamu alaikum and welcome to another lecture on signal and system and DSP. So in this lecture we are going to do addition and multiplication of the two discrete time signals. So in this video we'll learn how to perform two very important operations, that is the signal addition and signal multiplication. We'll use signals containing positive values, negative values and zero values. We can clearly understand concepts such as positive plus negative and multiplication by zero, or positive multiplied by positive, or positive multiplied by negative and negative multiplied by negative. These concepts are very clear to you in the arithmetic sense, but in case of variables and signals it's slightly confusing, and these are very important because they form the foundation of the convolution, which is one of the most important topics in signal and system. Digital signal processing, also other applications include the artificial intelligence and so on. So this visualization will help in building a clear understanding of the signal operations used in these areas. So for example, this is our signal number 1, x1 of n, and you see you can easily tell that this is basically a discrete time signal. How you know this is discrete? Because independent values, that is n. Okay, so n is your independent variable and it has integer values such as 0, then it has value of 1, 2, 3, 4 and so on, but it doesn't contain the in-between values such as 0.5 or 0.6 and so on. Again, on the negative side we have the signal. So I mean, it is a two-sided signal. So on the negative side, we can say that this index value is -1, this is -2, this is -3, -4, and so on. So hopefully you understand the difference between the digital, discrete time signal and the continuous time signal. So in case of continuous, you have the variables such as t, and the values are there. They are also continuous. So this is a discrete time signal, and let's talk about its amplitude. So its amplitude is, say it -7, it has amplitude of 0, -6 amplitude of 0, and at -5 it has amplitude of 1. Similarly, this is a second signal, and fully understand these values. So these are its amplitude. Say at -1 it has value of 4. Okay, and here it has value of 2 and so on. So that's all about this uh, signal. So let's move to the next one. So let's add these two signal. I have plotted both the signal here. So this is your x1 of n and this is x2 of n. Okay, so at the bottom is the resultant. So let's go point by point for a few examples. So you see addition of 2 0 will result into 0. So at this point this signal is 0, this is 0. Again at this point the signal is 1. The point is n equals to -5. Sorry, we jump here. Okay, so at this point the n equals to -5 and the signal has value of 2, whereas at the second signal has value of -1. So 2 minus 1 will result into +1. Again at this point we have signal of negative. Okay, say -1, and this one has value of -2. So adding -1 with -2 will result into -3. Similarly, this signal has value of -2, this has value of -2. So 2 -2 and -2 will result into -4. So hopefully you understand this is your 0 line. Okay, so anything above it is 1, and any positive, and anything below it is negative. Okay, so let's jump to -1. So at -1 this signal has value of 2, whereas this one has value of 3. Okay, so 2 minus 2 minus 3 will result into minus 5. Similarly, at 0, this signal has value of minus 1, and this one has the value of 1. So minus 1 plus 1 will result into 0. Again, here both signals are 0, so the sum is 0. And also, if we look at this point, so here the signal number 1 has value of say 3, and signal number 2 has value of say plus 2. So their sum will result into minus 1, that is minus 3 plus 2 result into minus 1. Similar argument applies for this, and this signal is 0 from plus 6 and towards infinity, and also the signal is 0 minus 6 towards negative infinity. So that's all about this one. Let's jump to the next, where we have the multiplication of the two signals. Let's have a view before going to the multiplication process. So here in this is in fact a larger one, the diagram comparison with the previous one. So here I think you can look at this one and you can appreciate and you understand. Here this one is very clear and you can clearly read the values and understand how the operation of addition is done. So shown on this slide are the two signals x1 of n and x2 of n, and their product is shown at the bottom. So okay, so let's do the multiplication. So you understand anything multiplied by 0 is 0. So from at minus 7, this signal is 0. This one is also sorry, this signal is 0. This one is also 0. So product is 0. Similar argument for this one. Now again, at minus 5, okay, this is n equals to minus of 5. So at n equals to minus 5, we have signal number 1 has value of 2, whereas signal number 2 has value of minus 1. So minus 1 multiplied by 2 will result into minus 2. So here we have this is minus 2. Then at next point, that is minus 4. So at minus 4, the first signal has value of minus 1, whereas the second one has value of minus 2. So minus 2 multiplied by minus 1 minus minus plus 2 multiplied by 1 is 2. So we see the result is 2 here. Now at this point again we have two negative values, so negative into negative becomes positive. Now this one is minus 2, this one is again minus 2, so minus 2 multiplied by minus 2 will result into plus 4. So you understand this is the zero line, right? So anything above it is positive, anything below it is negative. So again, similar arguments apply for this one. Let's jump to this one when n equals to, for example, minus 1. So at minus 1, we have the first signal equals to minus 2, whereas the second signal has value of minus 3. Okay, so minus 3 multiplied by minus 2 will result into plus 6. So you see this line drawn here. Okay, so this is plus 6. Then again at 0, this signal is minus 1 and this one is plus 1. So minus 1 multiplied by plus 1 will result into minus 1. Similarly, at this point, both the signals are 0. Even one is 0, then the product is 0. So for both signals are 0, this is 0. Again, this is negative. Okay, it has negative value, and this one has the positive value of plus 2. So their product will result into negative. So this is minus 3 and this is plus 2. So minus 3 into plus 2 will result into minus 6. Okay, again, this is positive, this is negative, so product will be negative. Okay, so this is minus 1 and this is 2. So 2 into minus 1 will result into minus 2, which is shown here. Again, at this point, we have this signal value, which is equal to 4, and this one is minus 1, so it should give you minus 1 into sorry, this is 2 and this is minus 1, so minus 1 into 2 will result into 3, something like this. These are not properly scaled. Now this signal has the value of 1 and this one has the value of 2, so 2 into minus 1 will result into minus 2, and for the rest, this one, both the signals are 0, so it will result into 0. Uh, so here is the product of the two signal. Sorry, mistakenly I have written the uh, addition, so this is not actually addition, this is the multiplication, right? So multiplication of the to signal. Okay, so here you can see this is slightly larger because only this product is shown on the whole slide, so it becomes very clear to you, right? So here we have value of say 6, here we have -6, right? And again this is the value of 3, and this is the value of 3, sorry, 3 -3, and this one is I think -4. So that's all for addition and multiplication. That's all about the addition and multiplication of the two discrete time signals. So let's have some homework. So I would suggest that you should multiply signal number 1 by 1.5 and signal number 2 by -1 and plot the resulting signals. Okay, and also add and multiply the resulting signals and plot them as well. So if you have any confusion, you can post. Even if you don't have any confusion, post your answer in the comment section and feel free to ask if you have any confusion. To summarize, we have used signals containing positive, negative, and zero values to understand importance of mathematical concepts. We also visualize these operations graphically using the discrete time plots. So these basic signal operations are extremely important because they are building blocks of the convolution, which is widely used in signal system, digital signal processing, communication, image processing, so many fields, including the artificial intelligence. So practice these examples and try modify the signal values yourself to observe how the resulting signals change graphically. So that's all from my side for today. So goodbye and see you in the next lecture.